In this tutorial, our mission will be to control a 4x4 video switcher using the AMX Basic Control Structure or BCS protocol. We'll then build the code necessary to parse the strings coming from our switcher. The BCS protocol document is a simple one-page document that's included in the resources folder as a part of this course. If you haven't already, download it now. For easy reference, I'll include it in my workspace. Right-click on the other folder and import it. It's labeled BCS Instruction Manual.pdf. Let's start by building the necessary pages and buttons on our touch panel. Open up the touch panel file. We've done plenty of touch panel work up until this point. Therefore, I'm going to fly through this very quickly so you can see what we need. Pause this tutorial while you complete this step so we all stay together. I'll begin by copying and pasting one of the source pop-up pages and rename it Video Switcher. In my new pop-up page, I'll delete all the old buttons and create new ones for my switcher buttons. I'll start with 4 input buttons, then I'll create 4 output buttons. I also need a take button, and finally, we need a button where we will display the incoming string from the switcher. Now that all my buttons are built, let's address them. Since this is a new page, we're obviously going to use a new channel port. If you remember, the last port we used was for the light sensor bar graph on port 7. So let's use port 8. The 4 input buttons are going to be channel port 8 and channel codes 41 through 44. The 4 output buttons are going to be channel port 8 and channel codes 51 through 54. The take button will be port 8 and channel code 61. Finally, the text box that we created is going to be a bit different. Up until this point, we've only dealt with the channel port and codes and level ports and codes. For this button, we're going to use address ports and codes. Remember back to one of the first lessons in this course? Address codes are used for AMX system to send information back to the button on the touch panel. In this case, we're going to parse the incoming string from the switcher and send some text to this button. This is also referred to as a variable text. We'll make this button address port 8 and address code 10. Okay, all my buttons are addressed. Let's add another source select button to our source bar. I'll call it Video Switcher, and I will need to add a page flip to my new pop-up page. On the release event, I'll choose Show Pop-up for my Video Switcher. That's it for my touch panel. I'll save it and close TP Design. So, let's learn a bit more about the video switcher we are controlling. I'll open up the BCS protocol document to see how the strings will be formatted going from AMX to the switcher. Go to page 6 in the manual, under Basic Command Strings. The first example shows how to execute a switch. The string is rather simple, uppercase CL and a number. This stands for change level. The level is referring to whether or not you want to switch audio, video, or both audio and video. For this exercise, we want to switch both, so the level we'll use is 0. Next is uppercase I and the input number you wish to switch, followed by uppercase O and the output number you wish to switch, and finally an uppercase T for take. After a string is sent to the switcher, it will send back a response string. Scroll down to page 8 for the command string responses. If the string you sent was in fact executed, the switcher will send back the same string you sent it. If an error occurs, the T at the end of the string is replaced with an X. That's basically it. I'll close this document and begin writing the code. As always, be sure we're working in the correct source code file. I'll shut down all source code windows and open up my lab master source code file. Let's begin by defining our new devices. First up, the switcher itself. It is going to be an RS-232 controlled switcher. The first RS-232 port is already in use by the DVD player, and we used port number 2 in our exercise code for our projector. Therefore, let's use port 3. We also need to define our new touch panel port. We'll call it DVTP_video SWT, and it gets 10001:8:0. That's it for defining our devices. Now, let's scroll down and create a button array. It will be a volatile integer array called nVideoSwitcherButtons. Inside the array, we'll put all of the buttons for our switcher. They were 41 through 44 for the input buttons, 51 through 54 for the output buttons, and 61 for the take button. Let's copy the name of our button array and scroll down to the bottom of our define event section. We'll keep the timeline event at the very bottom. So, just above that, we'll build our new button event. For the device to pass in, we'll use DVTP_switcher. And for the button channel number, we'll paste the button array name here. Inside the push handler, we need to do some sort of evaluation to keep track of which button was pressed. So I'll do a switch on button.input.channel. Then each of the case statements will be the button channel numbers. One thing we can do that you might not be aware of is stack case statements, like so. Case 41, case 42, case 43, case 44. Remember, these are the 4 input channels for our switcher. Let's create a variable to store which one of these input buttons were selected. I'll scroll back up to define variable and create a new volatile integer variable, and I'll name it nSelectedInput. Obviously, we're going to need the same thing for our output buttons. So, since we're up here, let's define another variable which we will call nSelectedOutput. Scroll back down to our event and let's now assign the selected button to our variable. nSelectedInput gets button.input.channel -40. Why did we put -40 in there? Remember, we are switching inputs 1 through 4 to outputs 1 through 4. The input button numbers were 41 through 44. So, if we subtract 40, we get 1 through 4. Next, let's add the 4 case statements for the output buttons. This will look very similar to the input. We need to assign the output buttons to the variable. nSelectedOutput gets button.input.channel -50. Now, we've stored the selected input and the selected output. We're just about ready to send the string to the switcher. But before we do, there are 2 more valuable keywords we need to cover. Those are ASCII to integer, or A to I, and integer to ASCII, or I to A. In the code editor, if we just type I to A and hit F1, we see a great explanation how it works. But simply stated, it's a pre-built function that when you send in an integer value, it returns the equivalent number as ASCII characters. This is going to be very useful for us because if you remember from the BCS protocol, all data must be sent in ASCII. Consequently, the A to I function does just the opposite. It takes the ASCII character and converts them to a decimal value. One important note of caution about using A to I, since it always returns a signed value. If you pass in a string like lamp hours -2000, ATI returns a negative 2000 because it interprets the dash as a negative sign. With that, we are ready to build a string. We'll create the final case statement, which is for the take button. We start with send string, and the device is DV video switcher. Open double quotes, open single quotes. All commands to the switcher start with uppercase CL. Next, add the 0 for audio and video. Here we use a capital I for input. Then we close the single quotes. Next is where we have to use integer to ASCII. So type I to A and insert the variable n selected input inside parentheses. Next comes the capital O for output, also inside single quotes. Then the output number, which also needs to be converted from integer to ASCII. And the string always ends with an uppercase T for take inside single quotes. Close the double quotes and add a semicolon. Now we have a properly built string that will be sent to the switcher as soon as the take button is pushed. In part 2 of this tutorial, we'll finish up this video switcher code by building a data event to parse the incoming string from the switcher.